Hey, so I'm assuming you just watched my previous video and that's why you're watching this one now. So in the previous video, we've explained a little bit what the Rigidbody player controller script does, and I explained a little bit of these values, and not a little bit, I explained most of them. And what we have that is not yet explained is the orientation, which is the biggest thing that we're going to actually dive into the code, and we're going to see how this all performs in the script and what's the code behind all of this. Okay, so let's go into the code. This is my script. Um, so first of all, here are all our variables, and this is the player camera and the orientation. We will see what is this in a second. And these are some private variables that we need for the script. Okay, so in the start, it's pretty standard. We just get the components and we have the jumps left variable, which is how many jumps we have left at the player. We just set it to the max jumps as a default and then get all the components. Pretty standard stuff. Same standard stuff is in the update function. We just get the input if we like press left, right, up, down, and if we press jump. Also here I already set a movement input vector, which is a vector that only contains values for if we moved on the z-axis and the x-axis, which will be translated later to the forward direction that the player is facing. Also pretty standard stuff, nothing too interesting. And next up we have the fixed update. So in the fixed update, the first thing we're going to do is we're going to rotate the body of the player to the direction that the camera is looking. And we do this inside the script in the fixed update because we need to synchronize the rotation of our rigid body with the physics engine. And if we do not do this in the fixed update right here, then just like the note I put here, I put it actually even here for myself, like when I were creating the script, so it's nice to have it. So it will cause jittery and unpredictable movements of the camera, like you will see the world jitter a bit if you rotate left, right. So you do need to put this in a fixed update, and once we put this in a fixed update, we can go on to the rest of the rigid body player script. Rigid body player controller, I mean, okay. After we do this, the first thing I'm doing is I want to see if the player is grounded, which is also very important. And to do this, I'm going to simply cast a sphere from the feet position of the player, which is right at the center of this line, like which would be, okay, like at this height in the center. That is where we're casting the sphere, and we are casting it to the negative direction of the transform up. So for example, if the player would be tilted right here, then the sphere would be right here. It would not go down. And if I enable the debug, I think it might work. Oh no, it doesn't because it needs a reference. However, I can tell you that it would simply like the sphere go like this. This would be the sphere. It would not go down. And a more extreme example, in this situation, the sphere would go like this and not down. This is a simple preference of mine that I did for the reason that I do not see my game changing the orientation of the player on the X or the Z axis. And if you see that your game will need to do this, then you might want to change this is grounded function to something more elaborate or more simple, whatever your choice is. So let's quickly look at this sphere cast. We're casting from the feet position, and we're adding a small offset to this cast. And the reason is that we want to start our cast just a little bit inside the player, and then we want to cast downwards to the player's orientation for the reason that we want to cover the whole space. So if we were to go in a paint, oh my god, this does not look appropriate, I'm sorry. If we go into paint, just like this, and this is our capsule, right? And this is the feet position right here. that we've defined there. Then we move just it a tiny bit up, like literally a tiny bit, for example right here, and then we cast a sphere cast from here to about here. So we capture all the space, and we do not have any holes in our cast. For example, if we were only to cast a simple sphere at the bottom of the player, it might have been something like this. And then we have a hole in our cast, and this avoids this hole. Anyway, this is grounded function may be very controversial because, well, each game might want to change it a little. But this is what I used for this one, and it works pretty well. I did not have any problems with it. If you want to change it, sure, you can go ahead and do that. There is no problem with doing it. So now we're going to continue. Next up, we are going to calculate the slope angle that the player is standing on. And if we go right here, this is what does it. So simply what we're doing is we're casting a ray from the player's from the, oh my god, I forgot how to say it. From the player's center, we're casting a ray from the player's center, so from the rigid body position, and we're casting it downwards. So we're casting it from here downwards, and we are casting it by at least half of the player's height. So we want to reach at least here for obvious reasons. And then we're adding the slope ray length, which is another length variable that will be used for extra distance on this one. And this is pretty obvious because otherwise the ray would just stop here. Instead, we're giving another extra variable to make it longer if we need to. And that is right here, slope ray length, currently set to 0.5. Then we're going to check if the ray has hit something, and if it did, we're going to return the angle between vector up and the normal of the surface that we have hit. And by doing this, if I were to draw it, for example, say this is a ramp we're standing on right here, and this is the normal to the surface, and this is vector up. So by knowing this angle right here, this is the angle, this is the angle in which we are standing. And if the ramp were steeper, for example, let's quickly make it steeper, so something like this, then now the normal would be more, and the normal would, I meant the angle between the vector up, the global vector up, and the normal of the surface would be higher. And if this angle exceeds a certain length, a certain scalar, a certain value that we assign, then we do not let we're going to not let the player move on to that slope. And here we just get the vector between the slope and the surface that we're standing on. If we do not hit, we just return -1 because we need to return something. Okay, so let's go back to the fixed update. So here it is, we get the slope angle, and right here we'll be getting back to this no, actually no, we can do this now. So remember how we have this extra gravity time after a slope, and basically we check, hey, if we are on a slope and if we just exited it, then we need a time frame of 0.2 seconds to apply extra gravity to pull the player down. Then here we need to know what's the last time that a player was on a slope. And if the last time is in this is in a time frame window, then we will apply extra gravity under some conditions that we will also see later. Oh, we can ignore this line. This was also something that I tried to do. Okay. Next up, we have if the player is grounded, that we reset his max jumps. We reset the amount of jumps left to the max jumps for obvious reasons. And then they apply extra gravity that we were talking on before. So let's jump into the function. We can actually, this is also not needed. So what we do, we anyway are going to apply extra gravity on the player to make him not float around because Unity's gravity is a bit wonky. And this is set by this value right here, by the gravity multiplier. Actually, I'm just going to do this like this, and good. Now this will be much better. And what else we do in this function, after we add the extra gravity in general, we want to add the gravity in case we exit a slope. And how we're going to do this? First of all, we're checking if the player did not press jump, then we're going. If the player did press jump, then we are not going to do this because we're going to bring the player instantly down, and we want to avoid that. However, if we did not press jump, and we are not grounded and not on floor, and on floor is just a function that checks that the current slope angle is less than the maximum allowed slope angle. So I'm going to go back to this. Where is it? Here, extra gravity. I've missed it. So yeah, if we're not on the ground and on a floor, if these two conditions are not met together, and if we're in the accepted time frame window that we set right here, then in that case we're going to apply our extra gravity and pull the player down. And this is how I avoid that wonky movement to not let the player float or kick into the air after he is moving. Okay, so then we have a standard jump. We just check if we're grounded or we have more than 0 jumps left. And of course we set the pressed jump to false. And in the jump we just apply the force upwards, so the player jumps. Oh, and also another thing I did, which, well, you might do or not based on your preference. I set the current velocity of the player on the y. I set his current velocity on the y to 0 before applying this force, because I do not want to just apply this force. I want to make the player jump. So if he's in mid-air and he's falling, first of all we're making him stop falling and then adding this extra force. Okay. The next thing we're going to do is actually apply movement to the player. So first thing we're going to do is we're going to get the current velocity, and we will need this because we want to cap his velocity to a specific max speed, like here. And this is pretty standard. We check if the player is grounded and if he's on a walkable slope, on a walkable surface. Then we just clamp the magnitude of his velocity and set his velocity to the clamped magnitude. However, yeah, that's actually this. There's no however. Oh, there is an however. If the player is not grounded and he exceeds his max velocity, then we only clamp his vertical velocity, and we do not touch the y velocity. So we want to make sure the player keeps falling, but only control the horizontal velocity. And we set it to the horizontal clamped, and we retain his y. So this video is again getting a little long, so I'm going to split right here, and I'll see you in like 2 seconds, I guess, or not. Well, we'll see.